All right. Hello, everyone. Welcome to this final ITS Davis seminar for fall quarter 2020, and a memorable quarter it has been. We should take a moment to acknowledge that ITS Davis is located on land that has been the home of Patwin people. We are honored and grateful that ITS Davis is able to use their traditional lands. Let's see. Let me do one little bit of business and then I will introduce our speaker. So as a reminder, students, you need to have submitted your questions for the appropriate number of seminars for the quarter. Please check in Canvas to make sure that you've got enough submissions there. Anne-Marie tells me that a couple of you missed submitting questions for seminar 2. So you're going to have to do the makeup for that. So please, all of you, just check that you've submitted stuff and so that we can give you your credit for the quarter. All right. Well, I am delighted to introduce today's guest speaker, Yingling Fan, who is a professor of urban and regional planning at the University of Minnesota, where she's in the Hubert H. Humphrey School of Public Affairs. She does really interesting work at the intersection of transportation, land use, and health, and that's what we're going to be hearing about today. She is the editor of the Journal of Transportation and Land Use, which was actually started at the University of Minnesota and has become a really important vehicle for publishing research in this area. A couple of weeks ago, I said when I introduced the speaker, I mentioned that she had a patent, and I said, I think this is the first time I've introduced a seminar speaker who has patent. Well, it turns out that Yingling also has a patent for a technology for data collection, and I think we're going to hear a little bit about that today. And then I'm just really excited to hear her talk, which focuses on this idea of happiness and is some really interesting work. There's a small group of travel behavior researchers who are really getting into some more of these psychological and mental health aspects of transportation. So yeah, really looking forward to this. And just as a reminder, I'd like to ask that students ask questions via chat. And those of you who are attending who are not students, you can ask your questions via the Q&A function. This is a course for our students, so we like to give them first priority for questions. And with that, please join me in welcoming Yingling.
Thank you, Suzanne, for your warm introduction. I'm very excited to be here. I'm going to share my slide, making sure that it works fine. Okay, so does it look good?
Looks great. Yep.
Great, thank you so much. My name is Yingling, so I'm very excited to be here and I'm very delighted to be here to share with you some of our work about the transportation happiness. And in fact, every time I present transportation happiness actually makes me happy. The work of transportation happiness is very much related to the technology that we were able to patent it back in 2017, 3 years ago. And also 2 years ago, we launched a startup based upon the technology, and the company is called Daynamica, Inc. So today here in this presentation, I'm wearing 2 hats. One is a professor of urban and regional planning at the University of Minnesota, and also co-founder and the CEO of Daynamica, Inc. The app development itself started actually 9 years ago. So it took a long time for us to eventually get to the point that the app we were able to patent the technology and launch a startup company based upon the technology. Because I'm wearing 2 hats in this presentation, so I'm required to put this statement in the presentation, and just to let you know that the conflict of interest is managed at the University of Minnesota. My presentation have 4 major components. First, I will talk about the challenge around the study and investigating transportation happiness. And now I'll talk about the solution. As you know, that the solution is heavily about our Daynamica technology. And then I will spend a little bit time to talk about some of the broad applications that our technology could have, in transportation as well as in health. And then spend the majority of the time to talk about our research around the transportation happiness. So some of the preliminary findings from our analysis of the smartphone data that are able to capture people's transportation happiness. Okay, so first component, the challenge. Well, the challenge here is that capturing travel behavior and experiences throughout the day is not easy. When we talk about the transportation happiness, we are talking about emotions, and the emotions are really time dynamic. It depends upon where you are, what you are doing, and also who are you with, right? So when we try to study transportation happiness, we must know, kind of capture time of transportation, travel duration, start time and end time of the trip. We also need to capture the spatial dimension in terms of origin, destination, and the trip trajectory. And also, importantly, we want to capture people's psychological experience that is very much time dynamic throughout the day. And we want to have a repeated measure throughout the day as well, because the experience of your first trip during the day is likely to be very different from the experience that you're going to have in your second trip or third trip during the day. When it comes to capturing travel behavior data and and the people's experience during trips, I think there are 5 performance dimensions that data collection tools needed to do very well. So I'm going to introduce you some of the existing data collection techniques that are out there, and how well those existing data collection techniques that perform in those 5 dimensions that I illustrated here. So the first dimension, is comprehensive attributes, because if you want to study about trips, travel behavior is a multi-dimensional, right? I'm talking about the time dimension, the spatial dimension, but you also want to know travel companionship, who you're traveling with.
Wait, who am I speaking with?
And the trip purpose there.
Oh, okay, yeah. Okay, yeah.
Somebody needs to mute. Miriam, can you mute?
All right, so I'm going to go ahead and talk a little bit about the comprehensiveness of the data that is very important when it comes to describing travel behavior. A type of the first type of data collection technique that I want to introduce when it comes to capturing travel behavior data is diary survey. So diary survey is very straightforward. So you record from the beginning of the day, your first trip, and then when did you get started? When did the trip end, right? And then what did you do after the trip, right? And then it gets to the second trip, right? You ask you all kinds of questions about each trip. So certainly, diary survey can perform extremely well when it comes to capturing comprehensive data. However, diary survey is not doing very well when it comes to data accuracy, when it comes to reducing respondent burden, when it comes to the ease of deployment as well as management. It's also very difficult to combine diary survey with wearable sensors. So it's difficult to integrate multiple data sources when you use diary survey. So why diary survey doesn't perform very well with data accuracy? Because diary survey essentially essentially is a recall, right? So you at the end of the day, you started to recall what did you do since the beginning of the day. So there's certainly a lot of recall bias associated with diary survey data. It's also not very good when it comes to addressing respondent burden, because if you think about a paper-based diary, you have to write down everything about your trip during the day. If it's a web-based diary, you have to type everything, right? So there's a lot of respondent burden. You have to enter. There is a lot of recall burden, and also need to provide a lot of input into a lot of records and they report a lot of attributes there. It's also not, quite difficult to deploy and manage. If it's a paper-based diary, you have to enter the data into digital format, and then potentially can be integrated with other data sources. So let me introduce you another set of data collection techniques. And this set of data collection technique originated from psychology, and it's called experience sampling. And often it could, sometimes it's also called EMA, ecological momentary survey. The idea of doing experience sampling, and this is really about capturing very accurate information about your experience at the moment. So traditionally, the traditional way of doing experience sampling is actually using beeper. So basically that when beeper sends a signal to the participant is supposed to write down their experience at the moment and what they are doing. Are they in the middle of the trip? And whether they who you are with, right? So it's all about that at the moment, what are you doing, right? So all the behavioral data and experience data is really at the moment data. So that's why it's called sampling, experience sampling. So it's not continuous. So the data is not comprehensive because it's not throughout the day, all your travel behavior and experiences. It's really at this time snapshot, at this particular time, what are you doing? Are you in a trip? And what's your psychological experience? So experience sampling perform extremely well when it comes to accuracy because there is no recall bias, but also at the same time it perform poorly on the rest of the dimensions because it's not being comprehensive based upon what I mentioned earlier. It's also, although it's the survey itself is relatively short at the time that people being surveyed. It comes with actually high respondent burden because this method is very disruptive to people's daily activity and trips, right? So it actually experience sampling doesn't perform well when it comes to low respondent burden as well, and it's not very difficult it's not very easy to deploy or manage, and when you combine data sources, it's relatively difficult as well. So now I'm going to introduce a third category of travel behavior data collection or travel experience data collection tools. And this third behavior do extremely well. This third category does extremely well on integration, on deployment management and the burden, but does poorly when it comes to data accuracy and data comprehensiveness. So this third dimension, we categorize it as a smartphone sensing plus AI, artificial intelligence. So one of the, a typical tool or a well-known tool in this category is the Google timeline, Google timeline product that Google actually captures. If you use an Android phone or if you don't use an Android phone, whenever you interact with a Google product, the Google will capture your location data. And then, over time, Google have a rich amount of location data, and they do artificial intelligence to do some prediction in terms of whether this location is your home or work, or this location is really about shopping. So with the smartphone sensing and artificial intelligence, like over a long period of time, once you accumulate enough information, you actually could do predictions about activity type. But smartphone sensing and AR essentially is very passive. There is no user interaction there. So therefore, it's actually zero respondent burden because there is no interaction with the user. But it does poorly with data comprehensiveness because a lot of the travel behavior attributes, for example, travel companionship or travel experience, right? How you feel during the trips are not sensible. There is no sensor in smartphone actually can sense that type of information. It's also in terms of data accuracy, because there is no interaction with the user, so the user cannot, confirm or correct some of the predictions, because we all know that artificial intelligence is unlikely to be 100% correct. So, without a user interaction or user annotation, therefore the data accuracy is not going, in that dimension, smartphone sensing plus artificial intelligence is not necessarily going to perform very well. I also want to mention that because the smartphone sensing and artificial intelligence, this approach always generate digital information. So it's relatively easy to integrate that information with other wearable sensors. So in terms of integration, whether the data are integrable with other data sources, I think smartphone sensing and AR are doing very well. It's also relatively easy to deploy. So whoever owns a smartphone essentially are generating that set of data. So then I think the solution here is essentially that reaching this, finding a tool that performs reasonably well in all those 5 dimensions, right? How can we create a hybrid version of all those existing tools so we have their advantages and try to address those disadvantages of the existing data collection methods. So we are proposing a hybrid intelligence approach in which smartphone and the human augment each other. So we integrate the smartphone sensing capability. What's also nice is that a smartphone itself, is a mini computer. So we actually can do what the sensing data can be mined in real time. We can use the sensor data and do data mining and machine learning and generate more meaningful travel trip and activity predictions. And then we utilize the smartphone's ability to interact with the user. So use a user-friendly interface so that allow user to annotate the data and also validate the data, validate the predictions that are generated by our algorithms. So essentially that, we call it a hybrid intelligence approach. So now let me talk about how this hybrid intelligence approach are able to perform reasonably very well in all those 5 dimensions. So first, data comprehensiveness. So this is basically the user interface, and this is what we call it a calendar view. And we are able to, based upon smartphone sensing data, we are able to automatically, develop algorithms that automatically segment activities from trips. Okay, so we separate activities from trips, and then for trips we are able to predict trip mode. For activities we are able to predict activity type. So the calendar view is pretty much actually automated, generated automatically by the algorithms in our app. And also the place dimension, because the smartphone has a built-in accelerometer, built-in GPS receiver. So we are able to capture the space dimension very accurately, right? The trip origin or trip destination, and then the entire trip trajectory. Whenever the phone is whenever the person is on move, we will, capture location data every 30 seconds. And then finally, that experience, right, capturing experience data. So once we separate activity and trips, so each activity and each trip, we consider it as a daily episode. So user can interact with any episode that is being predicted by the phone. And they can change the time if the prediction didn't get the time correct. They can interact with the app to change the time. They can change the type. They can split the episodes, and they can annotate. So we can ask questions such as, how did you feel during this activity, or how did you feel during this trip? In terms of accuracy and low respondent burden, essentially because we have smartphone sensing and data mining to auto-detect activities and movements of the trips to aid to facilitate the recall process. So therefore it's it gets to the accuracy, data accuracy, and the respondent burden dimension at the same time. We also allow human input to validate and optimize and augment auto detection. So those two, the smartphone sensing and data mining and the human input, kind of form a positive feedback loop, because if as the user providing more input, let's say if the user tagged this activity as a shopping activity, so next time the user coming to the same location, we can automatically tag it as a shopping location. So over time, that the algorithms will become more accurate when it comes to predicting activity types, predicting trips. And as the phone become more accurate, then the amount of user interaction required to make a correction or confirmation reduces over time. So therefore forms this positive feedback loop. In terms of how we manage and deploy, we have an all-in-one management platform, and where the study managers, they can automatically enroll user. So here I'm giving you an example. This video gives you an example how I add myself as a user to a study. So once the study manager in the dashboard, they enroll the user will receive an email receive an email, and in the email there will be information where to download the app and which user ID and passcode to use to activate the app. And also what's nice is that currently we have both iOS version and Android version in the Apple App Store as well as the Google Play Store. I don't have the current number, but in terms of smartphone ownership, each year the smartphone ownership is increasing. I think over 90% of the adults in the US now owns a smartphone. So you can reach a wide range of users compared to 10 years ago, when smartphone ownership is not that, was not as big as today. In terms of customability as well as the integration possibilities, it can be easily integrated with wearable sensors. So we have done some integration with stopwatch, with accelerometer, Fitbit also. We can do integration with the Fitbit. The reason that why we are able to do integration is that all the data in our app is organized actually by time, timestamps. So essentially, as long as the wearable sensors produce data, whether it's about physical activity or it's a physiological, data, heart rate data, as long as those data have timestamps, we can integrate with the data that our app can generate. So this is a graph here that's showing you that how the data that Daynamica generates in terms of activity and trip sequences, how it can be mapped to accelerometer data. So here you can see this person is very active. The physical activity is quite intensive in purple slots. The purple slot is leisure and recreation activity type. And this is just a simple illustration mapping to activity and trip sequence. Keep in mind that we also have location data, detailed location data, and all that amount and intensity of physical activity can be mapped to the spatial dimension very easily as well. In terms of customizability, we could, trigger any survey, by time, location, or event. So we could do a geofencing around, some known parks in the city. Let's say whenever people enter into the park, or we can trigger a survey on the app, so prompting people to answer a set of questions. And the survey questions can be anything, about particular behavior or particular location. We can also trigger surveys. So for example, we are helping a group of Texas A&M University researchers to study older adults' driving stress. So we could, we designed a survey for the researcher. Let's say that along the trip, please pinpoint the location where you felt peak stress. So that's the kind of customizability that the tool can have. In addition, there are questions that you may not be suitable to ask at the activity or trip level, right? There might be questions needed to be asked at the day level. So for example, we all know that in transportation that we're not only interested in observe the travel behavior. Sometimes we're also interested in whether there are trips that people canceled during the day due to many reasons. Let's say COVID-19, safety concerns. If we want to know those answers, we can actually, the app actually has the capability of producing day-based, day level survey questions. So I'm going to briefly talk about some of the applications that this technology can enable. And currently we focus on transportation, health, and beyond the transportation and health, we are exploring potential applications. Given the time limit, I will just talk about the application of this technology in transportation. We think that it is a flexible and a versatile technology for measuring and shaping human behavior and well-being. It's not just about data collection, and potentially we can create reminders and notifications, interventions actually that are context sensitive, triggered by time, location, or events. And it's not just about trips, because we are actually separating activities from trips. So we can ask people about their activities, detailed questions about their activities, and have in terms of their time use, so it can go beyond transportation. So I would just focus on transportation applications here. I think the technology certainly can provide better data to measure and shape transportation demand. We all know that individual behavior collectively form the region level transportation demand. And in fact, in all the metropolitan areas in the United States, it is required that those metropolitan areas, the MPOs, Metropolitan Planning Organizations, collect travel behavior data every 7 to 10 years. And those data, that travel behavior data, are used to forecast transportation demand by mode and to guide investment decisions. Do you want to invest in the public transportation system? Once you do the travel demand forecasting process, are there bottlenecks in your transportation network? Do you need to do expansion, right? Expand your transportation network. So essentially that the data can be used for demand forecasting, and can be used to inform infrastructure investment. And I also think that it's very useful to identify potential demand management policy or strategies out there. We all know that in transportation, there is this concept called induced demand, right? So you don't want to just simply, increase the supply in order to address the demand. You also want to do travel demand management. So the better data that we can capture also can help us to understand how we can do travel demand management. And finally, as I mentioned earlier, it's not just a travel behavior data collection tool. It can be designed to go a step further to generate personalized travel decision support and intervention. So I can give you an example. So, a newer version of our app, we actually working with the Twin Cities Metropolitan Council, and we are looking at that how we can, how we can promote a modal shift, right? When you try to promote a modal shift and then try to convince people to use more sustainable transportation modes, the general message telling people, kind of using sustainable modes is good for the society is not necessarily going to be very effective. So how can we create a personalized messages? As the app actually captures where people, people's origin and destination, the app can generate recommendations. So we, based upon the exact trip duration, trip origin, and the exact trip destination. So, we have a version of the app that essentially tell people, if you switch for this driving trip, if you switch to transit, to taking transit, what kind of transit routes are available, and then we give them specific information that what would be the changes in travel time, in terms of duration. We give them information that you can read how many pages of a novel, if you switch to transit, and then also that the carbon footprint and the potential physical activity benefits associated with that modal switch. Because that the one of the areas that we're very interested in is this experience kind of data, and the technology actually provides a very nice way to capture people's experiences throughout the day as they move around in the city. So it generates better data to measure and shape a transportation experience as well. And with the transportation experience data, we can visualize the happy and unhappy routes. And I will give you an example how we're using smartphone data to visualize the happy and unhappy roads. And as we pay attention to transportation experience, we are able to better connect the transportation with the health. We can also identify policies for equitable experience. We all know that transportation plays a role in equity. Because people's experience are shaped by their surrounding environment. So we want to make sure that the disadvantaged populations are not the unhappy people that in transportation, right? So we want to make sure that, so transportation, when you talk about transportation health, it's also important to touch upon the equity dimension. And finally, that I think it's important to incorporate the experience into performance evaluation of transportation systems. When it comes to transportation engineering and planning, traditionally we have always focused on the efficiency dimension. We tend to minimize the travel experience, right? So nowadays, because of the complete streets movement and the more study, I think Professor Susan Handy study about kind of physical activity benefits of transportation, people started to recognize that efficiency is not necessarily a good measure for transportation systems. And so we are talking about if we are able to measure transportation experience, we can further incorporate this new dimension into measuring the performance of transportation systems. So now I'm showing you a video just to illustrate this transportation happiness map we generated. And the map is actually alive. So if you go to maps.umn.edu transportation happiness, you will be able to get this online map. And you can interact with the map. So let's say that if I select driving and select weekday AM and PM rush hours, and try to see which road is the happiest road. And it's kind of surprising, but also not surprising. The happiest road is actually West River Parkway. So the River Parkway is a very scenic, so it's not surprising, but it's also surprising because it's not designed for commute, for peak hour commute there. So anyway, so this is just for illustrative purpose only, because our data were the data powering this map were only generated by 400 participants. So it's basically that it's not representative data, but it's also very interesting to us that with 1 week of data collection of just from 400 participants, we are able to kind of get data pretty much very covering broad geographic scope. Okay, so I have illustrated a little bit that how the technology generates better data that can be used and applied in transportation sector. Now I'm going to specifically talk about some of the research analysis that we did around the concept of transportation happiness. So first, I think it's important to acknowledge that the transportation is an unavoidable emotional landscape in our everyday lives, right? So if you think about commute, it's often the first activity people do outside their home, and that their mood during their work commute often defines their mood, general mood throughout the day. And not to mention that, kind of transportation is multimodal, and the kind of experience that people get from driving, from walking, and depend upon the community context, the experience can be very different. And also, I think this is the argument that I want to talk about why it's important to highlight transportation experience when we talk about design transportation systems. So in any US urban areas, significant portion of land area is devoted to streets, parking, public transit, bicycle lanes, and sidewalks. So, if you look at all the land areas that dedicated to transportation infrastructure, and I also include the private parking lots. In Los Angeles, I think some researcher did some calculation. It's over 50% of the land area is actually transportation related. So as a city planners, like I study urban planning, that if we use this more than 50% of the land, just for the sake of getting people from point A to point B, I think that's a major missed opportunity, right? We got to think about how we can shape the experience when people are spending time in those transportation related spaces. And a theory that I often use when we do transportation happiness research is this so-called broaden and build the theory of positive emotions. This, I wanted to mention that positive psychology, so this theory is very popular in the field called positive psychology. And the positive psychology is very young. So was created, I think, in late 1990s by a group of psychology researchers, because prior to positive psychology, psychology research tended to focus on negative emotions rather than positive emotions. Because negative emotions tended to be the source of mental illness, so there was a lot of focus on studying negative emotions such as anger, frustration, but not necessarily a lot of research on happiness, because back then, the conventional wisdom is that happiness is an indicator of well-being, but it's not a contributor of well-being. So being happy means that you in general you have you have a good fulfillment, but not necessarily help you to accomplish better development and growth goals. So what positive psychology, this subfield did in the subfield, researchers actually created the causal link. So this theory essentially indicated that positive emotions not only an indicator of well-being, but also a factor, a contributor of well-being. So how does happiness create enhanced health, survival, and fulfillment? Being happy will create novel thoughts, activity, and better relationships. So happiness has been found. Happier people are more creative, more productive. They have better social relationships, and they are more active also. Which is not surprising, because when we are depressed, we're more likely to shut ourselves in our home and not speaking to anyone. So because positive emotion create those novel thoughts, activities, and relationships, because of the broadening effect, there is a subsequent building effect. Because as you explore your neighborhood, you may find some additional activities to do. As you pick up the phone and speak to your family or friends, you may find a new job opportunity somewhere. So the broadening effect essentially have the subsequent building effect, where you actually build enduring personal resources, including social support, resilience, skills, and knowledge. And because of this building effect, you will have enhanced health, survival, and fulfillment. And what's more important is this positive feedback loop is, as you having this enhanced health, survival, and fulfillment, you're more likely to have positive emotions in your everyday life, and it forms this wonderful kind of reinforcing positive feedback loop. So if we think about this broadening and build theory, actually it could be applied to the spatial dimension, right? So it's, if you think about activity space or where people people exploring the city, happier people more likely to have a potentially larger activity space, discretionary activity space, and potentially that, and having that kind of, and potentially that lead to better human development. So from transportation perspective, I think it's very important to, as I mentioned earlier, have this equity perspective that when we create and design transportation spaces, we want to evoke positive emotions and reduce negative emotions for all. We wanted to actually address some of the existing disparities already out there in terms of mental health, in terms of human well-being. So this graph just to visualize the kind of data we are getting from the smartphone app. So this is a participant's 7 day of life activities and happiness. So as you can see, the thicker bar, and if a thicker bar represents the activity trip sequence, and the narrower bar illustrated in green color represents the happiness, right? So the darker green suggests happier moments, and the lighter green suggests unhappier moments. So it's not surprising you see that under the red blocks actually working time blocks, the happiness level is relatively low. And then under light blue blocks, those are leisure and the recreation blocks, the happiness level is higher, okay? Anyway, so, but by looking at this person's 7 day of happiness, it's difficult to see the difference, how travel behavior characteristics affects happiness. So we did some regression using our data. Again, the data set is from a survey we did back in 2018 in the Twin Cities region, where we captured a week of data from 400 participants, which generated thousands of trips for us. So emotional experience by trip mode. So when we do the regression and try to see what type of trips are more likely to generate more positive emotions, it's very clear biking trips and walking trips are happier than other trips. But it's also very important, also very interesting to see that when people ask how painful the trip was, people also reported higher painfulness when it comes to biking and walking trips. So you can be happy and painful at the same time. In terms of meaningfulness, also, you can see biking and walking are much more meaningful than other types of modes. In terms of stress, you can see car trips is the most stressful. Car is the most stressful mode. All other modes are associated with a lower level of stress. And the tiredness, bus is the only significant difference is bus versus other modes. So bus is the most tiring transportation mode. Net effect is essentially just we average the positive emotion and negative emotion coming with a composite index. So you can see that statistically biking and walking are significantly associated with a more positive and less negative emotions compared to other modes. We also look at the happiness by trip mode across neighborhoods. So it's very interesting. So our sampling approach was a geographic clustering sampling. So we were looking, we captured, we focused on 6 neighborhoods, and the 6 neighborhoods include 4 urban neighborhoods, 2 suburban neighborhoods. And then among the urban neighborhoods, we have low-income neighborhoods and middle-class neighborhoods. Among the suburban neighborhoods, we also have low-income and high-income suburban neighborhoods. So it's very interesting that the biking, when we look at the biking happiness, we only able to observe the happiness of biking in 2 neighborhoods. That is the St. Anthony Park and the Prospect Park. Those are the 2 urban middle-class neighborhoods. So essentially suggests that in suburban neighborhoods as well as low-income urban neighborhoods, that we just don't even have sufficient observations, biking trip observations, in order to generate the happiness data. And that the lack of biking trips in those 4 neighborhoods is also very important finding, because if biking is the happiest mode, we literally, the residents of those 4 neighborhoods, they don't have access to this very happy mode, right? So if we look at the walking happiness, you can see significant variation across the neighborhoods. So essentially suggest the lowest walking happiness is seen in Phillips, which is the urban low-income neighborhood. So certainly there are neighborhood disparities, and I think there is an equity perspective we wanted to pay more attention to. Happiness by trip mode and duration. This is a very interesting graph. When we did the comparison, in general, car trips are happier than bus trips, but the gap is only significant for trips lower than 30 minutes, which is not surprising at all, because if you're talking about the long driving trips, right? Longer driving trips are likely to generate less positive emotions and more negative emotions. But when you talk about long bus trips, actually not necessary that the increased duration will lead to decreased happiness, because you're just spending more time sitting on the bus instead of having that driving stress. So this is a very interesting, just to show that how mode actually interact with duration to affect people's happiness. This is one of my favorite graphs. This is a happiness by trip companionship. And so the recommendation is that you always travel with your family or friends. So when you travel with no one or people from work, you tend to have a relatively lower happiness. And it's also very interesting, the Y-lines, we call it a Y-line graph. The Y-lines, the shape is quite different. So if you look at a spouse, in general, the average is, traveling with spouse in general, very happy, but there is also the distribution. You're looking at the distribution that there are, fair amount of people when they travel with spouse, they are not very happy. With the data can help us to power this transportation happiness map, which I illustrated earlier. So I'm not going to spend more time to talk about transportation happiness map. We also did this analysis looking at which factors are the most important factors when it comes to predicting trip happiness. We find out that the mode is extremely important. So, whether you are doing car trip, bus trip, or biking trip or walking trip, pretty much is the most important predictor of your happiness during trip. Companionship is as important as mode. So who are you traveling with? The second tier of factors is activity during trip and the trip purpose. So whether you're listening to music or engaging in conversations, those activities during trips, are important. Not as important as companionship and primary mode, but also important. Trip purpose, whether you are traveling to restaurants or traveling to shopping activities, also a very important predictor. We found that leisure recreation trips as well as dining trips are happier trips. In terms of individual characteristics, we found age to be the most important predictor of transportation happiness. So now I'm going to get into a new set of analysis, and this analysis we just started to kind of analyze the sequence-based data, because I would say that we were just scratching the surface of the data. The data is so rich that we actually have sequence, like how each activity transits into trips, and then trips transit into another set of activities. So we started to analyze kind of how activity trip transition affect people's emotions. So I'm not going to spend much time to talk about this graph, but I will just show you the two cells that are really stark, shows a stark contrast, right? So if you look at kind of this bike and weight kind of column, bike and weight column, you can see that the very red right next to very blue. So red means happiness gains and blue means happiness loss. So if your previous activities was education, so you were in a classroom, and then the next activity is biking, you're going to be very happy. But if your next activity is waiting for a bus, you're going to be very unhappy. So then we started to think about other ways to take advantage of the sequential nature of the data. So one area, the methods we are borrowing is the DNA sequence analysis techniques that are out there. So if you think about the 24 hours, you can segment it based upon time intervals, defined time intervals. So let's say 30-minute interval or 5-minute interval. You can even have 1-minute interval. You can use the character, the string of character to represent the activity trip sequence throughout the day. Okay, so we consider that we say DNA of the day, your DNA of the day, and how we compare the difference. So you have your DNA of the day, and even you may have a different set of activity sequence tomorrow. Let's say every day your activity trip sequence could be different. So how can we measure the difference? So there is already exists this sequence alignment method out there. So you just simply calculate the added distance, which is the minimum number of insertion, deletion, and substitution needed to transform one sequence into another. So example I give is that from this first sequence to transform this first sequence to the last sequence here, the added distance is 3. So now we have a way to quantify the difference between any pair of activity trip sequences. So then we are able to actually cluster activity trip sequences. So anyway, so we started, so this work is preliminary. We just started to do some clustering of those activity trip sequences. We find 6 distinct clusters. So the first cluster, we call it the daytime activities. Those are the type of people that doing a lot of activity during the day, but non-work activities. Then we have another cluster of people, that they have a lot of home activity, a lot of time that actually spend at home. And then workday cluster, which those person days show a lot of work activity. And then nighttime, basically nighttime non-work activity, and then school day. And the last one is just the other, is just a lot of random patterns that we unable to classify, but it's only 30 person days belong to this other, so we basically not interpreting it in our finding. So we started to look at, kind of how happiness differ by, now I'm talking about general happiness during the day, by cluster and gender, the type of activity trip sequence you have during the day, and then by gender. We did not find any significance actually between gender and by cluster, but we did find significant findings when it comes to painfulness, this emotion, how painful people are across the day, throughout the day. We find that a female significantly report a higher level of painfulness than male. We were also able to look at the relationship and the difference by parenthood, looking at the female with kids and female without kids, so male with kids or male without kids. And not surprisingly, that the lowest, the group of people that report the lowest level of painfulness across the type of activity and trip sequence types is male, no kids. Okay, so male, no kids. Same thing with tiredness. We also find significant results when it comes to tiredness, this emotion, that male, no kids is the group that experiences the least tiredness throughout the day. So this, what I presented here is definitely a team effort. So there's a lot of collaboration that over the past 9 years that led to, kind of this technology and the happiness research. So I listed some of the our recent publications that utilize this smartphone data. And that concludes my presentation, and I welcome any questions.
Thank you. That was fascinating. I have so many thoughts and questions, but I'd like to open it up to students. So feel free to chat a question or let me know that you've got a question. And we'll start with Ray, if you want to unmute. I think maybe this question was answered, but if you want to pursue this, go ahead and ask.
Yeah. Maybe I didn't catch this. I was wondering, it is, first, thank you. It was really interesting topic. It is proven that physical activities promotes happiness and promotes like good feelings, positive feelings. And it is some sort of proven that positive feelings promote tendency to be more active and be willing to take more physical activities. So I was wondering, how did you control for this type of factors when you were measuring happiness and the mode of transportation?
That's a very good question. In fact, I got this question a lot. One of the advantages of this approach is that we get repeated measurements of trips. So because, as you mentioned that, sometimes it's often that some people just in general are happier than other people, right? There's a personality factor also. And then sometimes it's a wonderful day. I got a raise, so I got promoted, right? So that's why it's very important that in order to capture kind of those effects, you actually want to have repeated measurements. So for our data, so each person produced about 20 to 40 trips. So then we are able to not only compare between the people, their happiness levels, but also within this person, right? For this same individual, like whether, whether car trips are happier than biking trips, or walking trips are happier than bus trips. So I think having this repeated observations of trips and being able to capture both the inter-individual and the intra-individual difference is a kind of advantage of this data collection technique that, so you just get, you will be able to screen out those, those trends and be able to look at specifically the impact of mode on happiness.
Perfect, thank you. I have a follow-up question, Susan, if you let me.
Yes.
Thank you. How about availability of transportation modes and the choice of transportation mode? Have you measured that and how it affects the transportation happiness?
That's a great question. So I did not measure that in this study, but another researcher, actually they used our technology. So she actually specifically asked that, is this mode your ideal mode? So, and kind of information on the availability of the modes, right? So because sometimes that, if you think about this, part of the reason that biking is the happiest mode, maybe because that people who are biking are they chose to bike, right? And then people who do bus, it's because that there are no other available modes and they have to choose bus, right? So I think by asking the user, so asking the participants, actually, there was a question, I think, in her study that, is this your ideal mode? If this is not your ideal mode, then what is your ideal mode? So she was able to do modal mismatch, right? So whether this your selection of this mode matches your ideal travel mode for this trip, and how that predicts happiness. And she found that mismatch will predict lower happiness for sure.
Great, thank you.
Yeah, that's a really interesting question, I think, and the mode choice versus necessity. I mean, I guess the measurement of ideal mode gets at that somewhat, but it'd be interesting to also have some understanding of what their choices are. Yeah, and then back to the sources of happiness. That was also something I was wondering about, or just sort of separating mode from everything else. So I guess one thing you could do is look at relative happiness, sort of normalize each person, right, to their average happiness. But another thought I had was asking, measuring general happiness. I'm sure there are ways that people do that. And then that would be another way to kind of control for a person's general happiness. So is that something you thought about?
Yes, so we are looking at the data right now that how we can use the previous activity happiness as the base level of happiness. So whether you become happier or less happier compared to your previous activity, right? And then we use that instead of using kind of our raw data, we just use that categorical, exactly, the categorical, like whether it's a happier, same, or less happier as the as the outcome variable.
Yeah, I think that's a clever idea in that it takes account both their general happiness as well as the daily happiness, because everybody's happiness fluctuates. Yeah, very interesting. Trisha's got a question. Do you want to unmute, Trisha?
Yeah. Hi, thank you so much for your presentation. It was very interesting. One question I had was like, how are you quantifying happiness and pain and stress? Like, is it self-reported?
Yes, it is self-reported. So the question, we just borrowed the question used in American Time Use Survey. They have a well-being module. And the question is that on a scale between 0 to 6, how happy you are. 6 means most happy, and then 0 means least happy. So this question is repeated for all other emotion components. There were a total of 6 emotion components, 2 positive ones and 4 negative ones. The 4 negative ones include painfulness, sadness, tiredness, and stressfulness. And I have to mention that, in psychology, when you evaluate emotion or psychological experience, there are different types of scales that you could use, different instruments you can use. And a widely used one, actually, they got 10 negative emotions and then 10 positive emotions. So, some positive emotions, they even have love and joy, right? Negative ones, they would have embarrassed. Do you feel embarrassed? So American Time Use Survey simply picked the 2 positive emotions and the 4 negative emotions that can be used across activities and trips.
Yeah, great example of taking advantage of some really solid survey questions that have been used and tested. There, no reason to reinvent the wheel, students. Yeah. So especially, I think in this psychological realm, there's some really great instruments you can make use of. So students, don't forget to chat some questions. We've got a couple of outside questions and comments. One about biking. I was not at all surprised to see that bicyclists are the happiest, along with the walkers. I'm wondering if have you thought about using this for a bicycling related study in particular? And if not, maybe we need to talk to you about doing something.
Yeah, we have not actually specifically focused on biking behavior. And I think that the data we have is not very good to to focus on biking trips, because the happiness question is only asked at the trip level. So you can imagine with the biking trips, the beginning of the biking trip and the ending portion of biking trip, the emotions could be very different, right? And in the middle of the biking trip, right?
Yeah.
So I think somehow, we can certainly customize the survey where people can provide varied happiness levels throughout the trip, rather than, in our data set currently, this data set, we just ask how happy you are for this entire trip. The other disadvantage of doing that is that some trips actually multimodal. So walking to transit, taking transit, and then getting to the destination. Yeah. So we are not asking those kind of specific segment level happiness. We're just asking the global trip level happiness. I mean, that's why that the mode variable we are using is a primary mode. So we actually don't have the granularity to examine kind of how multi-mode segments in multimodal trips could have varied happiness levels.
Yeah, that starts to get complicated because we've got some interest in how the quality of the bicycle route affects stress level, and that can vary a lot, right, from street to street, block to block. But to have somebody be reporting that, especially while they're biking, so frequently, it's just, that's just complicated. And then I just want to note that the comment about biking came from Wes Lum, who worked for Caltrans for a long time and is now retired and does a lot of biking and is a very happy person.
Yeah, and I think
So
that
thank you, Wes.
one of the customization that we could use to capture the biking experience is that kind of the strategy we used for the Texas A&M University research, why they try to understand the driving stress of elderly people. That so when we visualize the route, user actually can use a slider from the route beginning and then towards the end of the route, and they can pinpoint where they have the peak experience, so peak stress experience or peak happiness. In psychology, there is this literature actually separating peak experience with net affect experience. It's quite interesting, so I just wanted to mention.
Yeah, and presumably they do that at the end of the trip, not while they're driving.
No, not at all. Yeah.
Maha has a question. Maha?
Yes, hi. Thanks, Yingling, for a really interesting presentation. So I was just wondering if you've done any interstate analysis on happiness derived from using rail or bus, and how important would the infrastructure's quality be in this case?
Yes, so this is a great question. So definitely, in one of the data graphs, we showed that the most tiring mode is the bus, but not rail. So certainly, I think in terms of a trip experience, the bus experience is very different from rail experience. Separated from this study, we actually look at waiting time experience during transit trips. We find out that the waiting time experience for waiting for a bus is also very different from waiting for rail for a train. Anyway, so I don't know what you mean by interstate analysis.
Longer distance trips? Is that what you were?
Oh no, I just meant across states, basically, like
I
California.
see.
Yeah.
I see. Yeah. So no, we have not done any of those. But certainly, my hypothesis is that bus experience will be very different from rail experience.
No matter where you are. Yeah. Yeah. Sarah, do you want to ask your question?
Yes. Hi. Thank you for the really nice presentation. I had a question about, you had spoken briefly in the beginning about how you were looking to measure health as well, because that's obviously one of the benefits of transportation happiness. I was curious about if you were collecting explicit health information, like if participants were reporting health conditions, how much they exercise and stuff like that, or if you did it in a different way. Specifically, I was wondering what you measured and how you measured it.
That's a great question, because when I say connecting transportation to health, I'm actually thinking that happiness is part of health, right? But I think with your question, you're asking that health could be a baseline factor affecting happiness, right? So we did, in our baseline survey, we did ask a question that in general, people's self-reported health status. So we have 5 categories from poor to excellent. We also have a disability question. And there was a significant finding that people with disabilities have much more negative emotions and lower happiness compared to people without disabilities.
Very interesting. Thank you.
Thanks. Ray, let's jump back to you. You had another question. Yingling, I think I mentioned that a lot of the students are taking the survey methods class with Giovanni, and I think this question comes from that. Ray?
Yeah, that's exactly where it comes from. Yeah, in Giovanni's class, the psychologist Kahneman came out and we talked about him, and I read in his book that the order of question has impacted one research regarding happiness. So they ask the students how many dates are they had in past month, and then they had whether they feel happy, and then they reversed the order of question, and the results were totally different. So I wanted to see how did you manage in your survey regarding like these really strong feelings?
Yes, so we did not actually address that in this particular study. So all the we started with I think that our first question was happy, and then all the 4 negative emotions, and then last question was meaningful. But we are thinking about, I think having the smartphone as the medium has this advantage because we can design it, have an algorithm that randomly generate those emotion questions. So instead of always ask happiness first, we can randomly say that, this time are we going to ask your sadness first? So that is doable, but we did not get to do that in this particular study.
I think your work on this could last the rest of your career.
I hope so, yeah.
So much to do. Yeah. There's a question from Lindell Price, not a student. Has happiness been incorporated into transportation or urban planning? And related to that, I love the happy roots map, but I'm wondering what can we do with that?
This is a great question, and also very timely because there is I searched online several times that whether there are Department of Transportation agencies already or cities already adopting this happiness concept when it comes to evaluating transportation. So Los Angeles currently, if you search LA Los Angeles Department of Transportation, they have a transportation framework and was adopted last year, so very recent. So I was like, oh, great! That's there are cities actually thinking about transportation happiness. Of course, like their definition is broader than the happiness definition I use here, because the reason they want to promote transportation happiness is to have this human-centered framework. Right, so not talking about mobility. It's really about people's experience, lived experience, right? So I was very encouraged seeing Los Angeles. I think they have a website about that transportation happiness framework. They also have a document online.
Yeah, that's great. Well, we've just about used up our time, so I'm going to take the prerogative of asking the last question, which is, if we were interested in using your technology, how does that work?
So we do charge, but we have deep discount for researchers. So we have worked with the researchers that kind of like have a very small budget. But anyway, so we have, I think, we are in the business for this will be our 3rd year. So we have a pretty mature system to provide the services and the products for academic researchers. In fact, most of our clients right now are academic researchers. So we haven't done any marketing yet. So because there was just so much to do, to get the app actually have a very good performance, and also making sure that there are so many phone models out there, and also maintaining the iOS and Android version. So we just started doing some kind of thinking about how we can accelerate, but we are not at the stage yet. We recently got accepted into National Science Foundation ICOP program, which is the Innovation COPS program. It's just designed for academic researchers who are interested in entrepreneurial work. So yeah, so we would love to work with you, Suzanne, if possible.
Great. Yeah, we'll think about that. And what, well, I'll just end with, so what's next on your list for research? I mean, you're doing a lot of supporting of the tool and working on other people's projects, but what do you most want to do with it?
Yes, so I'm actually hoping stepping off the CEO role as soon as possible because I really enjoy research, you know. So my, you know, I think this sequence-based approach is something that I really want to kind of go a little bit further, and then thinking about the emotion transitions, and then the idea of empathetic of cities, because we talk about equity a lot, but we don't talk a lot about empathy. And I'm very interested in ideas that how we can, you know, build the cities that are more empathetic, that people understand each other's experiences. So I think this type of data can be very helpful. You know, I think previously part of the reason that, you know, we were not able to generate a lot of research in the area is not because empathy is not important, but because that, you know, the data collection methods out there is not very good. It's not very convenient to get those type of emotion data, right? So I do want, as a researcher, I want to take advantage of that and study more about the transportation experience, the emotions, and how we build empathy in our cities.
I love that idea. I think that's a very nice place to end. So I like to invite students to unmute, and we'll do a nice thank you.
Thank you.
Thank you.
Thank you so much.
Thank you.
Thank you.
That was great. Thank you so much. And we'll get you out here to Davis when we can.
All right. Yeah. Have a wonderful evening. Bye-bye. Thank you so much.
Thank you. Thank you.